Today's next talk will be from Leah Verou. Leah is someone that I've known for a decade now, just short. We met on a cool fall day in Lyon. It was beautiful outside, clear day. Actually, no, I think it might have been rainy that day. Anyway, we were at a CSS meeting. It was also the meeting that she met her future husband, Chris, over there. It was an eventful day, is what I'm saying. But since then, Leah and I have worked together on a ton of things, and it's been a lot of fun. She's worked on some of my favorite specs, on images, on variables, and particularly on colors, where I've been very glad to have somebody who's not colorblind take over. She's also worked on so many interesting side projects, more than I could possibly name here without doing a talk dedicated to just her au revoir. So instead, I'll just name a few that I found the most interesting. She's worked on the Mavo.js framework, a way to do, or I don't know if it's not Mavo.js, just Mavo. A way to do declarative applications without ever having to write a line of JavaScript, but get some amazing functionality out of it. Worked on Prism.js, a wonderful syntax highlighter that I stole a lot of colors from for some of my own projects. And on Color.js, a color manipulation library based on good, solid color math that actually does things right, unlike every other color manipulation library on the web. She's also an author. We are breaking the British authors theme today because we have a Greek author now. Latest book is CSS Secrets, which goes into such incredible depth about the specs that I wrote, and I don't even know how she comes up with these things. But we'll be doing a little bit more of that today with variable secrets. So here to share more with us is Leah Verou.
Thank you for the great introduction, Tab. I feel I almost don't need to introduce myself anymore. But anyway, hi, I'm Leah. That's my Twitter account. Feel free to tweet any questions you might have, or even just feedback about my talk. Even if you just want to say, hey, Leah, that was crap, still tweet it at me. I would love to hear from you. And yeah, pertinent to this topic today, I've been an invited expert in the CSS working group for the last 10 years. I edit a bunch of specs. As of last year, I'm also a W3C tag member. The W3C tag is the committee at W3C that reviews proposals for future specs for architectural consistency and writes documents about the underlying architectural principles of the web. My day job is actually research and teaching at MIT. Tab mentioned Mavo. That's actually the project I'm leading at MIT. And as Tab mentioned, I've started a bunch of open source projects. Most of them fade into obscurity. Some of them have been quite successful. So before we start diving into CSS variables, a little bit about the motivation for this talk today. In 2020, I was the CSS chapter lead for the Web Almanac. The Web Almanac is HTTP Archive's annual State of the Web report. It runs a bunch of queries about how web developers use web technologies. And there's a lot of people that you've probably heard about that are involved in the Almanac every year. I did the 2020 one, and I didn't really get involved in the next few years because it was so much work. But it was quite rewarding. So one of the things that we studied was how people use custom properties. And just like I suspected, we studied a bunch of metrics, but pretty much every metric that came back pointed towards the same thing, that people are still, even though we got custom properties 5 years ago, people are still using them in a very basic way. Most of them are basically just used as constants. Custom property, variable depth is like, how many variable references do you need to follow to result in a certain, in an actual value? And like 2/3 of custom property uses were just declaring a property with a specific static value, like a depth of 0. And similarly, most custom properties were just declared on the root, essentially constants, colors, fonts, maybe widths, like page width and that sort of thing, but still essentially constants. So it got me to contemplate, like, we got these amazing, dynamically scoped, kick-ass reactive variables that are so powerful. And we're still just scratching the surface 5 years later. We're still treating them as basically glorified constants. Why is that? And I think the reason is that basically this is what we've been evangelizing since the beginning here. You can now have your colors, you can now have reusable colors, you can now have reusable fonts. But like, we don't really talk about how you can take advantage of the reactivity. And that is why I created this talk. So today's talk is structured as 4 parts. That is why I called it a story in 4 acts. And they're basically about 4 very seemingly simple components, things that we've all coded at one point or another in our career. I mean, the first 2 are basically just different button styles. But every one of these parts will teach us something or more than one things about custom properties. And without further ado, let's start with Act 1, the outlined button. And this is more of a recap of things that I expect most of you might already know. But still, it's good so that we can ensure that we all have the same foundation. So a button is probably the simplest possible component. And I'm going to be using component in this talk in a sort of liberal way. I mean, you might be using components in a framework. You might be using web components with Shadow DOM. But also, like, even any reusable blob of HTML, CSS, and sometimes JavaScript is basically a component. I'm not going to go into like how you are reusing your components. I'm not going to be using JavaScript or shadow roots or anything like that, just to keep things simple. But anything we discuss applies to all of these ways of using components. So here we basically have 2 variations of the same button, and there's some CSS applied to it. Some of it is hidden because it's like paddings and metrics and things like that. But there is, I'm showing some things here that are quite repetitive in a kind of annoying way. Like the main color for this component is declared 3 times. And this is exactly the type of thing that variables can help with, as you probably know. So we can just declare a color variable and then replace all instances of black with that variable. And right now we've specified a fallback in the rule itself, but we're going to fix this later. And the nice thing is that now we can basically replace all 2 rules that define our pink variation with just one declaration that defines this color variation. And we don't have to specify this in CSS. We can just specify it as an inline style. And while this can be an anti-pattern for presentational things, but CSS variables can be used for data. They can be used for all sorts of things. And customizing a component through CSS variables declared in a style attribute can be quite useful as a sort of alternative to attributes that we can actually access in our CSS. We're going to see an example of this later today. And of course, we can set these with JavaScript as well. Why not? We can, here, I'm going to just for the lulz, I'm going to have an on-click event handler. And yes, I'm writing this in the HTML because it's a demo, like, deal with it. And now every time I'm clicking this button, it changes its main color to something else. So, first takeaway. Now, I'm not saying anything new so far. CSS variables are just regular properties. In fact, they're inherited properties. Now, let's go back to this code. So, like I mentioned, we're currently providing a fallback because obviously we don't want to have to specify a color every time. We want some kind of default. But it's kind of an anti-pattern to just define the fallback in the rule itself. It means that anybody who overrides who wants to style our component needs to use at least the same kind of specificity that we've used in our CSS. And also it means that we are breaking inheritance. Like, somebody cannot set the color custom property like in the root and just have it inherit down in all of the components that understand it. So what can we do instead? As you probably would suggest, we can provide a fallback as the second parameter of the var function. And then, we can just repeat it everywhere. And it works. And we don't actually have to provide a value anymore, because if every single time we use this variable, we also include a fallback. But it's very repetitive. It's not dry. It's like every time we want to change the fallback, like if I decide that gray is actually a better fallback, I have to go there and replace it every single time. So what can we do instead? Well, you might be thinking, okay, so this talk is about variables, so I know I'm going to use a variable for this. And you know what? This would work. You could do something like this. You could assign this variable to another, this fallback to another variable, and then just paste it in every time, everywhere you were using black before. And it works. It gives you the right kind of flexibility. But isn't this awful? Can you imagine an entire design system written like this, with like this entire long thing every time you want to use a variable? So what can you do instead? What you can do is what I call pseudo-private properties, which is properties you don't expose in your documentation, but they're based, and they have the same name as the property you're actually exposing, but have the fallback baked in. So it's a convention. There's nothing special about an underscore. Like some people proposed, maybe we should start with a triple hyphen. Some people proposed, like maybe we should have more underscores because one's not enough. Like, you know, there are many conventions floating about. I think the underscore is starting to catch up, to catch on. But basically, this is the same thing that JavaScript developers had been doing for like 20 years until we got actual private properties in JavaScript. So if it's worked for JavaScript, it can work for us. And basically, that way we can just use a regular variable reference with just one extra character everywhere. And it also is, in a way, it's self-documenting because it shows you in the beginning of your rule, like for anyone reading your CSS, it shows you what are my actual exposed properties and what are their default values. So another takeaway, pseudo-private variables succinctly reduce fallback duplication. They reduce fallback duplication just as much as using a variable for the fallback, except reading values becomes a lot more succinct, and therefore code becomes much more readable. Now, another thing. Let's suppose, notice that right now, if I hover over a button, I get the hover effect immediately. But you know, CSS has transitions, so why not use them? So if I just specify transition 1 second, I get the background and the text color to just smoothly change. But you know, maybe I don't want that. Maybe I want a different effect. Like, maybe I want the border to sort of like grow inwards and give me an effect like this. So how can I do that? Obviously, backgrounds are a no-go, but I could sort of fake it with an inset box shadow. So let's try that. I would just replace my background declaration with an inset box shadow that just grows, no offsets, no blur, just spread, and it just grows inwards. And it works. But why did I do that? What am I trying to tell you? So what I want to demonstrate is that with this is that CSS variables effectively allow us to create a higher level styling API. Like we were able to encapsulate our styling in such a way that anyone who is using our component and has styled and has created a variation of our component with just specifying a different color value can just continue doing that. We changed the implementation. We changed from a background to a box shadow, but they didn't have to change their code at all because the custom property they set still worked. Imagine how this would have looked like before custom properties. We would have had to document that if you want to change the hover effect, you actively have to like override the hover rule and like set the box shadow declaration yourself. Because like there was no other way. You had to know how the hover effect was implemented and you had to actually override entire CSS declarations. Whereas now, like this is a sort of higher level abstraction than what we had before, that you can just set these key values and the implementation just adapts. And I think this is a very important goal when designing components, like to design them in such a way that you can easily change the internal implementation and people's code just continues working. All right, so now let's revert back to the background and remove the transition just to simplify things for the next thing. So let's suppose that instead of having a fixed pink variation, I want to have a rainbow variation where the primary color of my button animates throughout an entire spectrum of colors. So how would I do that? My first attempt would be I would set my color variable to something using a variable for the hue. And then I would use a keyframes rule to animate the hue. And let's animate it from 0 to 180, just like half of the hue wheel, just to see what we're doing. But eventually our goal is to continue animating around the hue wheel and give us like the entire rainbow of hues. We're going to keep the saturation, the lightness fixed at 16% and 50%. So we've applied the animation, but there is no animation happening there. It's just going from dark red to like this sort of turquoise color abruptly. Like, this looks terrible. So why is this happening? So this is happening because we haven't registered the property we're animating. So the browser's like, I don't know how to animate this. So I'm just going to flip at halfway through from one value to the other because I don't know how to interpolate this. I don't know that what you have is a number. But if we register our property and say, using an @property rule and say, hey, what I've got here is a number. It can only have numbers. Like, could you please animate it as a number now? And the browser's like, sure, I can do that. And as you can see, the moment we completed our @property rule, it started animating smoothly. And obviously now I can change it to have it animate throughout the whole hue wheel. So to recap, CSS variables cannot be interpolated unless you are willing to register them with @property. And there's also a JavaScript API called css.registerProperty. The JavaScript API came a little bit earlier, but at this point, browser support between them is basically almost identical. So why would you use JavaScript to register a custom property today? In most cases, it doesn't make a lot of sense. It's much easier to maintain your registered properties in CSS. There are some cases where the JavaScript API is better. If you want to register lots of properties at once, you can just do that. You can just do it in a loop. But also, for me, the primary use case for using the JavaScript API is debugging. Like, when you use the @property rule, you get no feedback whatsoever about where you went wrong if you screw anything up. It's just that your custom property doesn't work. It just doesn't get registered. And you're left scratching your head, like, what happened? What did I do wrong? Whereas if you're using the JavaScript API, you actually get nice readable error messages. So we could also register our color property in addition. And because every time we use @property to register a custom property, we also have to provide an initial value. All of these descriptors are mandatory. We cannot omit initial value, and we cannot omit the inherits descriptor. Well, we can omit initial value in only one case, if the syntax is a wildcard. But in general, we have to provide it. And notice that if we also register our color property, then we do not have to provide a fallback anymore, and the entire use case for pseudo-private variables goes away. However, @property will not really completely eliminate the need for this kind of thing, because @property is global. Unless you're defining @property in a shadow tree, in which case it is actually scoped to the shadow tree, thank goodness. But if you're just using it on your regular CSS style sheet, any property you define is global to everything. So if you're registering properties, for example, for a library or whatever, it's just everything is global. So in many cases, you don't actually want to provide an initial value that is global for every -- color property name, for example. Like -- color is fairly generic. Like, there are many subtrees in a document that might be using a color custom property, like to define their primary color or something like that. And you might not want to specify that all of them should fall back to black. For other cases, transparent might make more sense, or white, or gray, or whatever. So in some cases, fallback still makes sense. In other cases, initial values make sense. What you can't really do is combine them. Once you have defined an initial value through @property, the var fallback never applies, except in one case. If @property is not supported, and we're actually going to see towards the end of this talk how we can take advantage of that to provide fallbacks for cases where @property is not supported. And with that, let's go to Act 2, which I call the glossy button. Yet another button. I like buttons. There's so many things you can show with just one button. So as we've seen, CSS variables can be used as API, and there's a lot of component libraries that actually include custom properties as a regular part of their API. For example, Shoelace, for every component, it has a section, CSS custom properties, where you can see which custom properties it exposes. And at the tag, we also have a document called Guidelines for Creating Web Platform Compatible Components. And it lists a bunch of guidelines for web component authors. And most of them are pretty common sense. I mean, all of them are pretty common sense. But there is one in particular. It says, don't use custom attributes for styling like BG color. Instead, use custom properties or CSS shadow parts. So this makes sense, right? Why would you use presentational attributes? And yet, you will see that in every component library, there are a ton of presentational attributes. Like, you could argue that variant is semantic and not presentational, and I can accept that. But like, look, size. Why would size be an attribute? Why would outline be an attribute? Whether I want the button to be outlined or flat is an attribute. Why would pill be an attribute? I mean, these are very smart developers. It's not that they don't know that these should be presentational. It's that they cannot do it. Like right now, we cannot have conditionals that say, if the custom properties value is small, apply these rules. If it's medium, apply these rules, and so on. Like, we can't really have conditionals. In the near future, we will be able to do that in a limited way. Everybody's talking about container queries regarding sizes, but actually, if you look at the spec, style container queries are planned as well, and I'm a lot more excited about these. Because I think once this is implemented, it will unlock so many new opportunities for creating amazing APIs with custom properties. Like we could do a conditional like this and apply a bunch of properties. And then we would just be able to change one custom property and a bunch of stuff changes. But we don't have this yet. So can we fake it today? And there are some ways to fake it. And this is what this section is about. So let's look at the API first, and we're going to talk implementation later. So here, I have 4 buttons that are identical, basically. They don't have classes or anything. And I'm controlling which one is glossy through this property. I can turn it off, and you can see that now they're all flat. I can turn it on some of them, or on all of them, or on any particular one. And basically, as you can see, the button that has this declaration applied is the one that gets all these different declarations that make it glossy. And also there is a color custom property, because obviously. So how could we implement something like this? I mean, this would be kind of a nice API. It's not as nice as being able to have entirely custom keywords, like being able to say -- glossy on and off or whatever, or true or false, or yes or no, whatever you decide to call it in your API. But it's getting there. It's close. So how could we do that? The root idea is called a space toggle, and it was born after the realization that white space is a perfectly valid custom property value. And what does it do? It can help you turn entire parts of a declaration off. So here we have a linear gradient as a fallback to this custom property, and then a background color. So what happens here? Because foo has a value, the fallback doesn't get applied, and instead, when it gets substituted, we just don't get this entire thing at all. We only get the background color. Now, if we set foo to initial, then we will get the background color, because initial triggers the fallback. Initial is basically as if the same thing as if the variable hasn't been set at all. So with this simple idea, we're going to implement this glossy variation. So let's see how that would work. First, I'm going to copy this, the linear gradient. So right now, I have 2 hard-coded variations. Like I have hard-coded this. And I'm going to slowly use space toggle to merge these 2 rules. So first, I try it with the gradient. If the glossy declaration is at an on value, then it will apply the gradient. Otherwise, I'm just going to get the background color. And then gradually, I can do it with the box shadow as well. Like I copy the box shadow into the main rule and then fence it behind this var declaration. And same thing with border. Now, before we move forward, I want to point something out. So notice that here, if glossy is white space, we still get some effect. We don't get the same effect as if border wasn't there at all. If border wasn't there at all, what would we get? Here is if border wasn't there at all. We would get a border. That's the default user agent border. But somehow, what we're doing here is overriding that. So it's not the same as not having a border declaration. So what is actually happening here? What is happening is something called invalid at computed value time, and is a concept we had to invent to make CSS variables possible. So with regular CSS, if a value is invalid, say you say background 42 degrees, then the browser, as you know, throws away the entire declaration, and it's as if you hadn't written that declaration at all. We can't do this with variables. By the time variables resolve, the browser has already thrown away any other declarations it could have fallen back to. So that was a no-go. We had to invent some other behavior. So when you're using variables, and you end up, after substitution, you end up with an invalid value, then the entire declaration becomes invalid at computed value time, which is abbreviated with this very awkward acronym. I don't know if people try to ever pronounce it. I'm not even going to try. And what this basically means is that the declaration is treated as if it's unset. So remember, unset sets inherited properties to the inherit keyword and non-inherited properties to the initial keyword. It's basically the closest thing we have to a sort of reset. But it's still a value. It would still override the user agent value, for instance. So there are many instances where we get invalid at computed value time. So one is when we actively have an invalid value, something that doesn't make sense, like 42 degrees in the background. Another case is if we're using variables that simply haven't been defined and don't have a fallback. Or if the variable is explicitly set to the keyword initial, which is what we used in space toggle. And the var reference doesn't have to be the entire value. As long as you have a var reference that makes the declaration invalid, then it doesn't matter if it's just like one parameter of one very long function. It will still make the entire declaration invalid and thus treated as unset. Also, because fallbacks are applied at computed value time, fallbacks can also make a declaration invalid at computed value time. And this is what's pertinent to our example, to our demo. So if we have, if we set our variable to white space, then that is not an invalid value per se. But if after substitution, what we have is an invalid declaration, like background needs a value to be valid. It could be a color, it could be a background image, it could be something, but it has to be a value. You need to have something there. So if after substituting var foo, we just get we just get white space, that is an invalid value for background. So it becomes unset. And lastly, another case where we get this behavior is if we have cycles. Like if you're setting, here we have a cycle with two variables and they all become invalid at computed value time. Or we could have a cycle with one variable. This is the kind of thing that is actually, it looks very obvious when you talk about it. But it can actually be very easy to have a brain fart and end up doing this thing. Like you have a value and you think that you're inheriting it and adding one, like depth, for example. You might like want to set depth to depth plus one in your descendants. Like in JavaScript, we do this thing all the time, right? I equals I plus one. And yet in CSS variables, this is a cycle and causes the entire variable to be invalid. And thus everything that references it without a fallback also becomes invalid. Basically can screw up your entire style sheet. So now that we've explained why the border declaration does something, even when glossy is off, let's think about the next step. We only have one declaration left to unify these rules, the line height. And this is a little bit trickier because essentially what we want is an else. We don't want to just fall back to the initial value or the inherited value. We want to actually be able to specify what else is. What do we get if glossy is off? We want to get 1.1 when glossy is on and 1.5 when glossy is off. So how would we do that? It's essentially still the same idea, but inside calc. So we wrap the whole thing in calc, and then only we add the part needed to make it 1.1, like in this case we subtract, only when glossy is on. So when glossy is on, we get 1.5 minus 0.4, so 1.1, which is the value we wanted to get. And if glossy is off, that entire part is white space and like basically nothing. And we get calc 1.5, which is 1.5. So to recap, because I know that might be a little tricky, essentially what we want is the first line. And there are discussions in the CSS working group about how to give you the first line, how to give you a nice ternary function, basically. That would be lovely, wouldn't it? But since we don't have that yet, what we can do is the second line, the space toggle version. Like we basically have our first value, and then we figure out what is its delta from that value, what is the second value's delta, and we add or subtract that. And now that we've hopefully understood how that works, let's apply it on the opacity as well, so that we can have nice hover effects. Because we have both of these rules that specify a different gradient. So when we have a flat button, we have a flat gradient. And why are we using a gradient? Just because we want an overlay on our color, no matter what the color is. And then we have an actual gradient with a glossy button. So as you can see, we have different deltas. But it's basically still the same premise. And now the last thing remaining, notice that with our code so far, it works, but it uses clumsy white space and initial values. And if you try to hand this off to like another developer, they will tell you you're out of your fucking mind. Like, you expect me to use what? To toggle what? Like, are you kidding me? But you can use this in production. You just need to give them nice, readable names. And you can just do this in the root. So that you can use them throughout on every instance of space toggle. You can call them on or off. You can call them true or false. You can call them yes or no. It doesn't matter. As long as it's something readable instead of white space and initial. So let's add this finishing touch here. And that is it. Now, lastly, using the premise behind space toggle, like setting variables to white space is quite useful in a variety of things. One of them is getting nice graded interpolation. Like, as Chris will mention later today, there are a lot of things planned in terms of colors and gradients and interpolation. And one of the things is to be able to specify what color space your gradients interpolate in. Photoshop got this recently as well, and now we're getting it in CSS. So, however, if a browser doesn't understand what you're talking about, then you're going to get an invalid gradient, which is worse than sRGB interpolation, only marginally, but it is worse. So what you can do is you can set this token to white space in browsers that don't support this. And you can set it to NOKLab comma in browsers that do support this. The comma is important because, like, you need to have a first argument if OKLab if interpolation is supported, and no argument if it's not supported. And then you can just use it like this in every gradient, and you get the nicest thing the browser can do. On Chrome that doesn't support nice interpolation, you get like the usual sRGB interpolation, which you can see there, sort of. And on Safari that supports it, you get a nice gradient. And so some people have taken space toggle to the extreme. Like Jane Orrick has made an entire Minesweeper implementation just using space toggle. All right. And now let's go to Act 3, the bar chart, which is probably my favorite. So what are we going to make here? Here's a flexible bar chart component. We specify the percentages with numbers. And notice that as the number is shown on the bar chart, the number we specify, and also the color changes from yellow to blue, depending on the percentage we have. And this is all done with CSS, like no JavaScript. So let's take it one step at a time. I'm not going to show like the flexbox needed to arrange things that way, like that is beyond the scope of this talk. So the first thing is we want to output the actual percentage we have. So we write a before, a generated content rule, and we try to do something like this. So many people have tried this, and like, I keep seeing these questions like, why doesn't this work? So if we think about it, what have we done here? We have these custom properties, and then we are trying to output them. So we might notice that like, hey, I have a percentage here. Maybe I can't actually output a percentage. Maybe I should change my API to use like pure numbers. So we can try that. So we've changed our API to use numbers. And then to enable our height to work again, we actually need to multiply it by 1%, because we can't set height to a number. Height 42 means nothing, but height 42% does mean something. And notice that in CSS, you have to actually multiply it by 1 and the unit you have. Like if you have a number and you want to convert it to a unit, you need to multiply it by 1 and the thing the 1 of the unit you have. Like to convert it to a percentage, you multiply it by 1%. To convert it to pixels, you multiply it by 1px, and so on. However, when you have a unit, a number with a unit like 100 pixels, and you want to convert it to a number like 100, you can't do that today. There is literally no way to get to a number once you have something with a unit. In the future, you'll be able to divide with units as well. It's already in the spec. I don't think there are any implementations yet. And that is the story for at least a few years now. It has been in the spec for a while. Like, I don't know, Rachel, can we get any implementations of this? That would be nice. But right now, once you have units, that you're stuck with units. So I would suggest, like, unless you're 100% sure that you're never going to need anything else, use variables for pure data, like just plain numbers. You can always convert them to something else in your CSS. But if you put CSS values in your variables, you can't do anything with them. And this is especially important when you're using JavaScript to set these variables, because if you need to set another variable, then you need to go back to JavaScript and change the JavaScript code. It's not just a matter of like changing the same CSS file. Whereas if your JavaScript is sending a number to CSS, then CSS can do whatever with that number. You don't need to go back to JavaScript. So what can we do to actually output the number here? Because even when we switched to numbers, we still don't get any output. We still don't get the number being shown there. So the thing is, content doesn't accept numbers or percentages or pixels or anything of the sort. Content only accepts strings. So what can we do here? We can do what I call the counter trick. What is called the counter trick. So instead of setting content directly to your variable, you set a counter to your variable, and then use that counter. And the entire point of that counter, you don't plan to use counter increment anywhere. The entire point of this counter is so that you could output this number. And as you can see, this works. So to recap, content only accepts strings. You can convert numbers to strings, however, through counter reset. But let's look at it a bit more closely. Does it work? Does it really? For most of these bars, it works, but one of them is saying 0%. Look at it, right here. So why is this not working? The reason this is not working is because it's not an integer. You can't say counter reset to, you can't reset a counter to 84.21. Like, it just doesn't work. Counter reset only accepts integers. So, should we just give up at this point? If you know me at all, you know that the answer is definitely not. So what if we could convert the number to an integer? Wouldn't that work? But how could we possibly convert a number to an integer in CSS? So there is another trick to do that. And of course, it involves the add property rule. And it wasn't actually me that came up with this trick. It's Anna Tudor, who does a lot of brilliant stuff. So if you define a custom property as an integer, that as a custom property that only accepts integers, then you can set that custom property to your number inside calc. You also need, the calc part is mandatory, even though you're not doing any calculation. And then you use that property instead. And just by the fact that you're assigning it to this custom property, it converts it to an integer. It rounds it. If you're wondering if it floors or seals or rounds, it rounds it. And as you can see, now it works. I mean, we're not getting the entire number, but we probably also didn't want to, like we don't have enough space. So you can convert a number to an integer by just assigning it to a property that is registered as integer in calc. And if you want to control how it's rounded, like whether it's floored or sealed, you can just use the old math trick of adding or subtracting 0.5. And yes, this is a hack. So is there anything planned for the future to improve this? Yes, there is. In the future, we're going to get proper rounding functions in CSS. And they will round not just numbers, but like anything. You want to round your length value to like multiples of 50 pixels, you would be able to do that. And in the further future, we won't even need the counter trick at all, because we are discussing adding a function that lets you convert any value to a string so you can actually output it. Essentially, the console log of CSS. And now the last part. Notice that we also got a different color on every bar. It was ranging from this kind of yellow to this kind of blue. And this is the same, this is an HSL, this is a range of HSL colors that have different hues, the same saturation and slightly different lightnesses. And what we want is to get the yellow when P is 0, the 100 when P is blue, sorry, the other way around. When P is 0, we want to get yellow. When P is 100, we want to get blue. And when P is anywhere in between, we want to get the corresponding interpolated value. So how can we do this sort of thing? So we could do it ad hoc, and you've probably done this sort of thing before, maybe not for colors, but for other things, like start thinking. So we want to go from 0 to 190. So I'm going to use 50, which is my first value, and then multiply the range with a number from 0 to 1 that I'm going to get by dividing P with 100. And then, like, I can do the same thing with lightness. It's a range that goes the other way from a bigger value to a smaller value, and it's a percentage, but the same thing still applies. I start with 50%. And then I multiply the remaining range with like a number from 0 to 1, which I can get from P by dividing it with 100. And in fact, I will copy it because I'm lazy. And then I can put it all together by using it in an HSL function. And just like that, I got the range I wanted. So that works. And to convince you it works, I'm also going to vary this so you can see that it actually works as you're changing the variable. However, it's a little bit ad hoc to have to do this manually every time. So this is basically a special case of what is called linear mapping or range mapping or linear range mapping. You have a range, you want to map it linearly to another range. There is a formula to do this in CSS, but it's kind of difficult to remember. So because I'm lazy, I made an app with it. That's the URL. If you find bugs, let me know. But like, it works with whatever percentages. It works with whatever your variable name is, whatever values you want to use in the range. You might have to sometimes simplify the formula. It gives you a little bit, but it works. And also, you can use linear mapping is like so much more powerful than what we've seen so far. You can do conditionals with it as well, as long as they're numerical conditionals. But there's a lot of things that you can do with numerical conditionals. So essentially, conditionals are also linear mapping, but you don't care about the range at all. You want a value when your variable is 0 and another value when your variable is 1, and you don't care for what's in between. So you can do it that way, and that has the advantage of being a lot more readable than what we've seen with space toggles. So remember with space toggles, the space toggle version of the line height looked like this. So you had to specify the other value through a delta. Whereas with this method, both values are right there in your CSS. And you could even assign this thing to a variable like is not glossy or not glossy or something, and then it becomes super readable. And with this method, you could also do logical operations, like not is just subtracting from 1, A and B is multiplication or is addition, but you also need to use min or clamp to clamp it to not become bigger than 1. I mean, this is basically Boolean algebra, just translated to CSS variables. You can do NAND, you can do XOR, whatever. Like all the logical operations you know and love work here as well. So with linear mapping, we can use the same variable to control multiple things, either continuously, as we've seen with colors, like throughout a range, or discretely by using specific values. And one of my favorite examples is this one using SVG. This is the SVG for these eyes. And like, we have this property, property here that if we set to random, like to certain values, we can figure out that 25 pixels gives us eyes that look all the way over there, and 75 gives us eyes that look all the way over there, and 50 gives us the middle. But that is kind of nonsensical, and if we change our SVG slightly, a tiny bit, then we need to modify this as well. Whereas range mapping allows us to abstract this away into a look variable that goes from 0 to 1, and we know that like we can predict what each number will give us. But also, it means that this variable basically decouples input from output. Like where the eyes look is decoupled from how we obtain this number. So this number right now is set through CSS. But also, we could set it through JavaScript. We could write an event listener. And ideally, when you're writing JavaScript that sets CSS variables, you should aim to make it as generic as possible so that you don't have to go back to the JavaScript and adjust it for a slightly different use case. So here we're just going to follow pointer moves everywhere in the entire document and set a mouse X property and a mouse Y property. And again, because we want it to be generic and flexible, we're going to set it to a 0 to 1 number that is a percentage of where the mouse is in the viewport. And actually, we don't need mouse Y at all in this use case, but we set it anyway, just because this way we can use these variables on anything that requires the mouse. And now we can set a look to that. And as I'm moving my mouse, it just adjusts. And the CSS that is specifying the center of the circles is still the same. All that changed was how I'm specifying this look variable. So range mapping also allows you to decouple input from output in that way. And now the last thing, and we're going to need to do this a little bit quickly because I'm running out of time. So this is a speech bubble. It's implemented as you would expect a speech bubble, like the pointer is one pseudo element, the character is another pseudo element. positioned absolutely, clip path for the pointer, and so on. And I'm using these properties to tweak certain aspects. You can see how it adapts to different values. And there is one thing here that is a little bit tricky. The rest is pretty straightforward. And I've already done most of it here. However, notice that the offset between the character and the pointer is wrong. And it becomes more wrong the more the character size changes. And why does this happen? So the reason this happens is because when this character size variable is inherited down into the after pseudo element, then what is inherited is not the actual length of 3ems. It's not the number of pixels this translates to. It's just the syntax token, 3em. So it's basically equivalent as saying here, like my font size is 3ems, and then my margin top, like the pointer height here, is 1em. But because it's inherited as a syntax token, the 1em there is not the same 1em as it is on the parent. We are not inheriting the pixel value of that. We are inheriting the 1em length. But that translates to 3ems because we're now in the child that has a different font size. So how could we fix that? Again, add property to the rescue. We can register our custom property. And then I'm going to skip ahead a little bit because we're running out of time. So if I register my custom property, you can see that this was fixed instantly. And I can now change the character size and it just adapts. I can change the pointer height and it just adapts. And this is because I said to the browser that this is a length, the browser is now interpreting it as a length. And what is inheriting down is the actual length, not the 1em token. So relative values inherit as syntax tokens unless the property is registered. And thus, it's a corollary that if you register it as a length, we can pass down ancestor font sizes. This is especially useful in these cases where you want to set the font size of a child to 0, and then you want to get back to the ancestor font size on a descendant, which is what happened to me when I was styling a select menus, and I needed to use an opt group element as a grouping element. I didn't actually need a label or anything. I just needed a grouping element around a bunch of options. And there was no way to get rid of this gap, this annoying gap that is there normally for the label. You just can't get rid of it in any other way. The only way I found to get rid of it was to set the opt group font size to 0. It's a terrible hack, I know. And then if I set the font size to something other than 0 in the descendants, then I can see my options again, but the gap is gone because the gap depends on the opt group font size. But notice that I can't just set the font size to 1rem to revert back to the ancestor font size because the ancestor font size might be different. So I can use this trick to, and I can set the parent m here and inherit that value, but without registering it, I'm just using 0 here because I'm just inheriting down the 1em token. But if I register it, what I'm inheriting down into for the parent m property is the actual length. So it lets me revert back to the parent font size. However, the problem is that if the property is not supported, if that property is not supported, like this is why I deleted it to show you what happens. I don't get any of these options. This is pretty bad. This is not graceful degradation at all. This is pretty bad. In the previous cases, if that property wasn't supported, I get a slightly uglier result or I don't get an animation. But here, I get a very bad result. So I need to do something about it. Especially since that property currently is not supported by a bunch of browsers. I mean, the fact that it's supported by Chromium-based browsers still gives it a 70% market share, so it's not negligible at all. Gone are the days where we could say that, oh, it's just one browser that supports it and therefore it's negligible and I'm not going to use it. But still, we can't ignore the 30%. We need to provide a fallback. So there are many ways. One way would be to detect at property support. It's very simple. We just detect if a given interface is present and add a certain class. And then we can just use it as a descendant of that class. But can we detect that property with CSS alone? I sort of gave you a hint about that earlier in this talk. So can we use at supports? That was my first guess. What if I declare a property? What if I register a property and then assign something invalid to it? Like if I declare it as a color and then assign a number to it, surely that should be invalid. So it should fail in at supports. But notice that it's not working. My rules here are applied just fine. And this is because at supports checks parse time, syntax, and at parse time, everything works just fine with registered custom properties as well. Their syntax is only checked at computed value time. There's a very good reason for that. For regular properties whose syntax is checked at parse value time, the reason this happens is because the definition does not change ever. Like background will have the same syntax when your page loads and it will have the same syntax when your page, when your tab closes. But with at property, you could add at property rules with JavaScript. You can remove them. You can change them. You can do whatever. So the browser can't be keeping around all sorts of trash from your CSS just in case they become useful. So instead, it's checked later. So things can change. But what we can do is take advantage of inheritance. So we can declare a property as non-inheriting, and then we set it to a value at an ancestor, and then we use a fallback for when the property is not defined. And as you can see here, I'm going to get green only when at property is supported. If you load this slide in Safari, you will get red because at property is not supported there. And we can use this here. Whoa, okay. Or we can't. Never mind. This is the first talk I give with this like script that basically automates myself. So I'm surprised it took this long to see a bug. So now, what is the conclusion? Is this just a pile of hacks? Like, should we do all of this? Was that like something that is amusing to watch, but then we go and write CSS the way we've always had? Like, is it all a steaming pile of hacks? So in most of the examples we saw today, the hacks were in the implementation, and the API and the hacks were employed so that we could expose a nice API to other people styling our component. And I think that is actually worthy, even in production, even in libraries, even in like code other people use. Like, you gotta do what you gotta do to expose a nice API. And if what you gotta do internally is use hacks, then so be it, because you can always change the implementation. In the future, when CSS is better, you can go and change the implementation to something nicer. But APIs are much harder to change. And also APIs are used a lot more than, like the time you spend changing implementation code, even though it can be a lot for like very high stakes implementations, it's still a lot less than the time spent collectively by people using your API. So if using a hack and making your implementation slightly more complex makes things easier for people using your API, I think that's a worthy trade-off. Again, this is not a license to write crappy code and not care about writing code that's understandable. But sometimes you have to make trade-offs. Sometimes there are tough decisions to be made, and you have to choose between having a nice API or having a nice implementation. And if using hacks allows you to have custom properties that are independent, that set conceptually independent things that allow you to just set each thing with one property, that allow you to use like readable properties to set certain things, and so on, then I think the trade-off might be worth the hacks. So that's what I had for today. Thank you very much.